Welcome back, everyone. I'm Professor Ayman Alzaid, and this is Lecture 4, 3 Subsets and Proper Subsets. Now, before we dive in, take a look at that diagram on the right. You see two circles, and notice how set B sits entirely inside set A. Every single element of B is also sitting inside A. That relationship, one set living completely inside another, that's what we call a subset. And once you truly understand it, you'll start seeing it everywhere. In database queries, in type systems, in logic proofs. So let's get into it. Alright, so our objective today is objective 1 through 3, determining whether one set is a subset or a proper subset of another. By the end of this lecture, you will be able to find subset and use the subset symbol correctly, find proper subset, and know exactly how it differs from subset. Test whether A is a subset of B by checking every element of A systematically. Apply the special rules for the empty set and for equal sets. And list all subsets of a small set using what we call the power set. These skills will show up directly on Module 1 homework and the Module 1 quiz, so pay close attention. Okay, let's define subset carefully, because the definition is deceptively simple and getting it exactly right matters. A is a subset of B if and only if every single element of A is also an element of B. Not most elements, not almost all of them. Every element without a single exception. Now formally, and this is worth writing down, A is a subset of B means for all x, if x is in A, then x must be in B. That's the logical definition, and it will come back when we do formal proofs. Let me show you what this looks like with numbers. Let A equal the set containing 1, 2, and 3, and B equal the set containing 1, 2, 3, 4, and 5. Now we check every element of A against B, one by one. Is 1 in B? Yes. Is 2 in B? Yes. Is 3 in B? Yes. Every element of A passed the check. So A is a subset of B is TRU. And look at the diagram, A sits completely inside B, just like those nested circles. Simple idea. Powerful consequences. Now here's where students sometimes get confused, and I want to make sure you don't. There are two subset symbols, and they mean slightly different things. The first is subset, written with the line underneath. A subset of B simply means every element of A is in B. And here's the key point. A is allowed to equal B. If A and B are identical sets, A is still a subset of B. That's perfectly fine. The second is proper subset, written without the line. A proper subset of B means A is a subset of B, and A is not equal to B. In other words, B has to contain at least one element that A doesn't. Let me show you the difference with a quick example. Take A equal to the set containing 1 and 2, and B equal to the set containing 1, 2, and 3. A is a subset of B, true. A is a proper subset of B, also true because B has that extra 3. Now change it. A equals the set containing 1 and 2, and B also equals the set containing 1 and 2. A is a subset of B, still true, because equal sets are subsets of each other. But A is a proper subset of B, false. They are the same set. No extras, not proper. That distinction right there, that's what the exam will test. Master it now. Good. So now you know what a subset is, let's talk about how to actually test for one. Here is a clean 3-step method. Use it every time. Step 1, list all elements of A. Write them out explicitly. Don't skip this step. It's easy to miss an element if you're working in your head. Step 2. Check each element of A against B one by one. For every element, ask yourself, is this in B? Step 3. Draw your conclusion. If every single element of A is in B, then A is a subset of B. True. If even one element of A is not in B, stop right there. A is not a subset of B, and you don't need to check the rest. That last point is important. One failure is enough. You can stop immediately. Let's try it. A equals the set containing 2 and 4. B equals the set containing 1, 2, 3, 4, and 5. Is 2 in B? Yes. Is 4 in B? Yes. Both elements passed. A is a subset of B is 2. See how clean that is? 3 steps and you're done. Alright, let's build some intuition with 6 examples. Go through these carefully. Some are straightforward and some have a twist. Example 1. A equals the set containing 1 and 3. B equals the set containing 1, 2, 3, 4. 1 is in B, 3 is in B. A is a subset of B. True. Clean pass. Example 2. A equals the set containing 2 and 5. B equals the set containing 1, 2, 3, 4. 2 is in B, good. But 5 is not in B, stop right there. A is not a subset of B. One failure, done. Example 3. A equals the set containing A and B. B equals the set containing A, B, and C. A is a subset of B, yes. And A is not equal to B because B has that extra C. So A is a proper subset of B, true. Example 4. A equals the set containing 1, 2, 3. B equals the set containing 1, 2, 3. Identical sets. A is a subset of B, true. But A is a proper subset of B, false. They're equal. Remember that distinction. Example 5. A is the empty set. B equals the set containing 5, 10, 15. Now this one surprises people. The empty set is a subset of every set, always. There's no element in the empty set that could possibly fail the check. So the empty set is a subset of B. Always TRU, no exceptions. Example 6. A equals the set containing 1, 2, 3. B is the empty set. B has nothing in it, so there's nowhere for 1, 2, or 3 to go. A is not a subset of B. False. 6 examples. Notice how example 5 is the one that always catches people off guard. Keep it in mind. Now I want to give you 4 special rules. These are the ones that show up in proofs and on exams, so memorize them. Rule 1. The empty set is a subset of every set. We just saw this in example 5. It's always true, no exceptions. Why? Because there's no element in the empty set that could violate the condition. Mathematicians call this vacuously true. The condition holds simply because there's nothing to check. Rule 2. Every set is a subset of itself. A is always a subset of A. This is called the reflexivity of the subset relation, and yes, it will come up in proofs. Rule 3. 2 sets are equal if and only if each is a subset of the other. This one is huge for formal proofs. If you ever need to prove that 2 sets A and B are equal, here's how you do it. Prove that A is a subset of B, then prove that B is a subset of A. That's the standard technique. You'll use it throughout this course. Rule 4. Transitivity. If A is a subset of B and B is a subset of C, then A is a subset of C. Think of it like nesting dolls. if A fits inside B and B fits inside C, then A fits inside C too. 4 rules. Write them down. Here's an extension concept that ties everything together, the power set. The power set of A, written P of A, is simply the set of all subsets of A, every possible subset, the empty set, A itself, and everything in between. And here's the formula you need to know. If A has n elements, then the power set of A has 2 to the power of n subsets. Let's verify it with a real example. Take A equal to the set containing 1, 2, and 3. That's 3 elements. So the power set should have 2 cubed equals 8 subsets. Let's count them. Subsets with 0 elements, just the empty set. That's 1. Subsets with 1 element, the set containing 1, the set containing 2, the set containing 3. That's 3. Subsets with 2 elements, the set containing 1 and 2, the set containing 1 and 3, the set containing 2 and 3. That's 3. Subsets with 3 elements, the set containing 1, 2, and 3. That's 1, and that's A itself. Add them up. 1 plus 3 plus 3 plus 1 equals 8. Exactly 2 cubed. Formula confirmed. 2 things to always remember. The empty set is always in the power set, and A itself is always in the power set, no matter what A contains. Before we wrap up, let me highlight 3 mistakes I see students make so you don't make them too. Mistake 1. Mixing up the membership symbol and the subset symbol. Here's the wrong version. 3 subset of the set containing 1, 2, 3. That's incorrect. Why? Because 3 is a number, an element, not a set. Elements use the membership symbol. You write 3 is an element of the set containing 1, 2, 3, but the set containing 3, subset of the set containing 1, 2, 3, that is correct, because the set containing 3 is itself a set. The rule is simple. Use the membership symbol for elements, use the subset symbol when the left side is a set. Mistake 2. Thinking the empty set cannot be a proper subset. Students sometimes assume proper subset means you need real elements. Not true. The empty set is a proper subset of any non-empty set because it satisfies both conditions. It is a subset and it is not equal to the set. Mistake 3. Treating subset like a size comparison. The set containing 1, 2, 3 is a subset of the set containing 3, 2, 1, 2. Why? Because they are the same set. Order doesn't matter in sets. Subset is purely about whether elements are contained, not about size, order, or which set is bigger. 3 mistakes. Now you know to avoid them. Alright, let's bring it all together. 5 key takeaways from today. 1. A is a subset of B means every element of A is also in B. Always test it element by element. 1 failure and you're done. 2. A is a proper subset of B means A is a subset of B and A is not equal to B. The sets cannot be identical. 3. The empty set is a subset of every set, and every set is a subset of itself. No exceptions. Ever. 4. To prove 2 sets are equal, prove subset in both directions. A is a subset of B, and B is a subset of A. This is the standard proof technique, and it will come up again and again. 5. A set with n elements has exactly 2 to the power of n subsets, and they're all listed in the power set of A. Solid foundations. Every topic from here builds on these. Congratulations on completing Lecture 4. 3. Subsets and proper subset. You now have the tools to determine subset relationships between any two sets, identify proper subsets, apply the special rules for the empty set and equality, and count all subsets using the power set formula. In our next lecture, we cover objective 1 through 2, the number of elements in a set, also known as cardinality, including how to count elements in unions, intersections, and complements. But before then, here is your practice challenge, and I want you to actually do this one. List all subsets of the set containing A and B. How many should there be? The set has 2 elements, so the power set has 2 squared equals 4 subsets. Write them all out. Then for each one, ask yourself, is this a proper subset of the set containing A and B or not? It should take you about 5 minutes. Do it. It will lock in everything we covered today. See you in the next lecture.